Hi everyone, we continue to explore our database tool. Last time I stopped at the point where I moved the clock from another program. I simply copied it but didn't connect it. Now I will connect it. We have this great function, seconds to date time, which we use together with conversion to arc, that is from a number to a rotational position. And now I will make a sub-diagram from this, a sub-VI. I select everything that I need. I leave indicators only, edit, create sub-VI. Let's open it and make sure that everything is in place. I will name the icon clock. And I will save this sub-VI in the project folder under the name sub-VI clock. And now if we go to the project itself, we see that this sub-VI was saved in the general directory. I will now move it to the sub-VI folder and save the project. And now let's check how the clock works. I run the program. The clock works as you can see. So let's move on to our functions. Today we will look at insert record. I select the table into which I want to write my record, and I will enter some random values here. What exactly they are is not important right now. What matters is that we see the principle of how the insert function works. I fill in each cell in the first row, I press the insert record button, and this will be the first case. Now let's try filling in several rows. Oops, not here. Here instead, I'll fill it in here as well. So here it is, I filled in 3 rows. This will be the second case. I fill in the whole row except for one cell. I leave one cell empty. This will be the third case. And one more case. I also skip one cell, but I also write into a cell that is outside the table. And now if my cursor is here, yes, the button is hidden, not shown, but when I move into a cell inside the table and press insert record, what I wrote outside the table is erased. This is the fourth case. And the fifth case is when I completely fill an entire row in all columns. Then I skip 1 or 2 rows and fill in one or several cells below. And this will be the fifth case. We will now look at all of this on the programming level, but you probably noticed what I have in the background. Before I tell you more about it, I will remove everything unnecessary. Delete record. Yes, I'm using the delete function now, removing the records. And what's important to say here is that the changes that you see in the table on the user interface, the same changes are happening in the database in the background. That is, everything that I wrote and everything that I deleted is visible not only here, but it's also happening in the database itself. And not only in this table that you see. So now let's talk about what you see on my screen. This is the SpaceX logo. Let's take a small detour. Last time I promised to share some insights with you, maybe secrets or maybe not really secrets. Here he is, thinking, will it fly or not? But in reality, if you try to find some real information about this, it won't be easy. Here we see the face of a confident person. Of course, no one will reliably tell you how Elon Musk earned his billions, And in general, you know, they say this: if you ask a billionaire how he made his billions, he will gladly tell you about it, but he will never tell you how he made his first million. And here we already see that one of the monitors, there is our program. And since we are already talking about Elon Musk, of course he didn't come into the business world just by chance. The roots go back to his family background. His grandfather owned a diamond mine in South Africa, so we can assume that he didn't start from nothing. Then there was PayPal, Tesla, and finally SpaceX. In between, there were many other ventures. If you want, you can always find more info about this. Here I can say for sure that these are our dashboards. But that's not the point. And it's not even about how Elon Musk managed to get a government contract with an unlimited budget for space exploration. By the way, you won't be able to find information about that anywhere anymore. What interests us more in this case is what exactly led to SpaceX getting such development. So here it is. Well, of course, I think everything is clear to you now. The central monitor is our LabVIEW program. The program that we are now exploring, learning, analyzing, and will use to do great things. Now a little insight. As you can see, here is a post written by Mike. And Mike says, I work at NI, which makes LabVIEW, which runs mission control at SpaceX, who launched a spacecraft to the ISS today. Then he clarifies what exactly is shown in this picture. This is mission control at SpaceX. All those screens are showing LabVIEW. And here is a post by Pascal on LinkedIn, also with a photo of mission control at SpaceX. And what does he say here? He says, did you know that SpaceX uses LabVIEW for its mission control operations? And here people leave comments, and there are even comments in German here. Someone is replying to him. I don't know this language, maybe it's not even German, but it's clear that in this photo, the control room, the mission control room, where space flights are controlled, and on the central screen they have LabVIEW. Well, of course, let's go to official sources. For example, on the National Instruments website, the use of LabVIEW at SpaceX for various prototypes is described in quite a lot of detail. We won't go deep into details now. I'll just say in a few words that the program we are working in is used very widely and interestingly in companies that are rapidly developing. Again, the same, Tesla. Here we see on the Tesla technology side, LabVIEW, 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 everywhere. Let's also look at Amazon. Here in this picture you see the configuration for sending data to the cloud. Amazon S3 storage. From the LabVIEW Cloud Toolkit for Amazon Web Services, AWS. I think everyone is familiar with this service. Let's look, for example, at NASA. By the way, NASA stands for National Aeronautics and Space Administration. Here I found one interesting secret group. What are they talking about here? Let's take a look. Diadem. This is also a National Instruments product, just like LabVIEW. What other LabVIEW products are there? If we start talking about all of them, they have a fairly extensive product line. And we still have a lot to learn and explore. Here I have a link open to LabVIEW products and we see many applications. Oh, and here is Diadem that they were talking about in that NASA group. It's here as well. So yes, there are a lot of applications. And if you learn to effectively use at least some of them, you will be a highly sought-after specialist. For example, a kernel specialist salary here in Silicon Valley starts at $1 million a year. I think a national instrument specialist in all these applications would be valued at no less. Well, yes, so we were talking about NASA. Now I will show you some very secret insider information. Straight from the NASA archives. Here we see right away from the first pages that this is about LabVIEW and NASA. Of course, we're not going to study all of this. We have a different task today, to understand where we can apply our knowledge. But I can tell you a top secret from this document. These are the applications that were built using our program. And here they are, NASA LabVIEW-based applications. Ultrasonic measurement system, X-ray spectral mapping system, X-ray live testing system, new cloud absorption radiometer. And if we scroll a bit further down, we see diagrams, graphs, charts that are already familiar to us. Yes, all of this is LabVIEW. That means that using our knowledge, we can apply it not only in industrial applications, but also for scientific discoveries. By the way, interesting news about NASA is that the NASA hangar is now being transformed. I just drive by the NASA center almost every day, and this is what it looked like literally a month ago. And this is what it looks like now. Something secret is being planned there. When I find out, I will tell you, of course. Let's continue. Let's see what we have with NVIDIA, for example. I'll just type NVIDIA LabVIEW into Google search and go to the link on the National Instruments website. And here you see a toolkit that was created for NVIDIA libraries. And this toolkit is included in the VI package manager. We already discussed how to use it. Next, let's see how Intel is connected to LabVIEW. Here we see the Intel RealSense application. Here we see how you can work with Intel peripheral devices using our program. And let's see what Intel's website has to say about LabVIEW. Here in the search, LabVIEW is entered. And as we can see, there are a lot of results. That means we can confidently say that Intel is very closely integrated with our program. Now let's look at Boeing. There is also information from an official source that Boeing measures aircraft noise reduction using an IPXI and LabVIEW. And I also want to show you one more secret document from a large company, Lockheed Martin. This is an American defense and aerospace corporation. There are 76 pages, so of course we won't immediately find everything we need, but if we type LabVIEW into the search here, we can see that the company also actively uses our program. And if we scroll down to the images, photos, and graphs, we can see the Lockheed Martin control room. Here you see a wind tunnel operation room. And here on all the monitors, you see LabVIEW. So, as you see, these examples are almost endless. I mentioned only the top companies, and maybe they are top companies because they use LabVIEW. Well, that's a rhetorical question. If you're riding a train, know that all radio systems were tested in LabVIEW. If you go to a restaurant, know that all dishwashers use LabVIEW programs. If you drive in a car, know that many automotive components were tested in LabVIEW. If you end up in a hospital, know that much of the medical equipment is built using LabVIEW. And in general, there is probably not a single event in your daily life that in one way or another is not connected to LabVIEW. Well, basically, this is my answer to those who doubt that our program is useful. If you've never heard about this program and about LabVIEW tools, then I can assume, forgive me for my judgment, maybe someone won't like this. I can assume that the internet is overloaded with tutorials on programming languages that are easy to explain, easy to get code for, especially now with the help of ChatGPT. But with those programs, it's often problematic to build something substantial, something complex, for a product that can be used to generate profit, advanced technologies, for scientific discoveries, and in general something that simplifies work instead of making it more complicated. Like, for example, PostgreSQL, which is practically impossible to integrate in an automation process, especially one that operates in real time. Now I think you understand that we are using a very advanced tool. Of course, you need to know how to use it, like any tool. But if we find the key to understanding it, learn to think and create, and not just type text code while being afraid of making a syntax error. Here I came across an interesting reel that I also want to show you. And here's my translation of it. Before, I didn't understand why programmers work at night. You can just stop and continue in the morning. And then I realized, if I get distracted even for 1 or 2 minutes, there is no way I'll figure out later what's written here. An interesting observation, right? Of course, you can turn any programming language into a dummy. It will look like a dummy and work like a dummy. Now I will ask ChatGPT to generate some kind of nonsense code for me. I already prepared the phrase here. Write me the most nonsense C++ code that works but doesn't make any sense. Here you go. As an example, text code that kind of works, but is written in a completely nonsense way. Do you think this doesn't exist in object-oriented programming? For example, in our LabVIEW program, you can also wire graphical icons together in such a way. And maybe it will work. I don't know. I don't even want to start figuring it out. Of course, we will not do anything like that. Everything that we analyze here, as you can see, everything you see in our episodes, in our programs, is very structured, logical, and clear. So let's get back to our program. I'll close the SpaceX logo. And we are looking at the insert record function. I have a table open. So, when we do insert record, we are inserting, or rather writing, a record into a row, and then we press insert. And here it is. The values have been written into our database. Here it's important to say that when we write these values, it's not guaranteed that they will appear in order in the database. That doesn't mean the row will appear at the bottom, at the top, in the middle, or at the end. A database works in such a way that our row can appear anywhere. We can find out where it actually ended up only when we display the database in a table on our screen. To organize the data, we always use sorting. I'll now go to a more populated table. We already discussed sorting before. I'll just quickly show you. Sort by column. I sorted by voltage and then went back to index. You see that the index is all mixed up. We press sort by column and all the numbers are back in order. There you go. Well, today we are looking at insert record, and now let's see how this function works on the programming level. I press power off and go directly to the case in the block diagram that controls our insert record button. As usual, our program is executed from left to right. The first thing we do is a check. If the number of rows in our main table is equal to the number of rows in the duplicate table, that means no changes have occurred and we go into the true case. In that case, we get a pop-up window with the messages nothing to insert, meaning there is no record to write, the row is empty. And this function is working for inserting new rows. Here it's important to explain where DB table 2 comes from. You see here DB table and DB table 2. So first let's look at where the DB table 2 control is located. I could click find like this, find indicator, but I won't do that so I don't shift all my layout settings. Instead, I'll just move the front panel view to the left. And here you see the hidden table, those indicators and controls that we do not want to use on the main user interface. These are fully functional windows that participate in our program, but we hid them from the operator. And why do we place them on the left? This is a LabVIEW good practice to keep unnecessary indicators on the left side. This is because if we didn't define the fixed size for our interface, then when using expand window, the button to open the window full screen, it always expands to the right side. So the left side will always remain hidden. So where does our hidden table database table 2 get populated from? And why do we need it? Let's look at where it is filled from. To do this, I find all local variables. I'm only interested in write, and here we have 8 of them. Let's go to the first one. The first variable is written at program start. Here both of our tables are cleared. The second variable is populated during refresh table. The third variable is populated in the create table case when a table is created. The fourth one is in the DB table insert case. This is exactly what we are analyzing now. The fifth one is in the sort by column case, the sorting that you also saw today. Another variable is in delete record, the function that I also used today. When I deleted records, I had added to the table at the beginning of the video. The seventh variable is in the replace cell case. And the eighth one is in the DB search case, database search. Let's return to our DB table insert case. So, why do we need the second table? The thing is, as we've already seen, when forming an SQL command, we need the current value and the future value. In this way, table 2 stores the current value and table 1 stores the future value. Now let's see how this works in our functions. So, if we edit a row, the equality condition is not met, because the number of rows in table 2 and table 1 is no longer the same. Therefore, we move to the false case. Current value and the future value, as well as the table name, are passed to the sub-VI DB insert to table. And how this sub-VI works, and much more, we will explore in the next episode. That's all I've got for today. Thank you for joining LaPlante Tech. If you have any questions, please leave them in the comments. If you learned something new today, give this video a like and subscribe to learn more from upcoming episodes.